Hi guys. Hi guys. Hi guys. Hi. Hola. See. Hola. See. See. Hola. See. Hi guys. Welcome to Learning Electronics Repair. Okay, so I have a battery. Just check this is a good one. Oh yeah, 9.78 volts. That's plenty. Yeah. Let's put this one in and see if it works better. Well, it was working well. It wasn't bleeping. So, just while we're in here, you can see the PCB. This bit seems to be like soldered on afterwards, the one where you put the sockets. Oh, this must be the current shunt, this thing here on the 10 amp range, so it obviously measures the voltage across that, which will have some resistance, so that's how the 10 amp range works. Put it together. Oh, is it interesting? Can you read this, guys? So, this instrument contains no operator serviceable parts. Screw removal by qualified persons only. So, whoever made this is saying that I can't change the battery. There's an email address for this company. Who made this thing? I'll have to see if I can find who makes this and email them and ask them why I'm not permitted to change the battery. Because that's what it's saying. You can't change the battery, which seems like silly. Warning, to avoid shock, remove inputs before opening. Okay, fair enough. Close cover before using. Fuse 0.5 amp. 250 volts. How does that work? On the 10 amp range. Oh, I assume that the 10 amps only goes through the shunt and doesn't actually go through the fuse. So, where's the fuse? Oh, this doesn't want to. Oh, it will come out if you undo the two screws. Let's have a look. Let's have a look. Where's the fuse? I assume the fuse is not used as serviceable either. And yet I would think that by definition a battery or a fuse is like supposedly used as serviceable. Okay. It's come apart without damaging it. It does if you undo the other screw, I think. Still something holding it in place. I don't want to break it because I want to test it. I don't want to damage it, I want to actually test it. So there's like a little clip by which side. Let's have a look. Push that back. Does it come out now? I think I might have broken the clip. This is glued in or something, guys. So, where's my torch? Oh, the torch is in the van. Well, I don't see any components on the other side of this board at all. Just like the switch on the contacts. We might have to break it later, guys, because I want to see where this fuse is, yeah. But right for now, I actually want to try it. But that switch covers like the whole back of this PCB. And I'm looking like, yeah, it looks like that's how it also connects to the display, effectively. I can't, at the moment, see a fuse. Could be an SMD fuse, of course. Maybe I'm looking in the wrong place there, guys. Maybe it's an SMD fuse. I wish I had to try to take this apart. Okay. Okay, so we've solved that little problem. Let's try again. So now it doesn't work. What have I done to it? This is my low ohms, my milliohm meter. So on this range, it should give 50 milliamps, and this will be 100 milliamps. Okay, that's the test current. So let's have a look. We'll try on this first. Okay, so we go to milliamps range. I'm just going to effectively connect the two to each other. So let's see what current goes into the meter. Yeah, so is it going to be 50? No. Well, you know why? Because I have that in the wrong place. Put it in there. Let's try it again. So I'll set a bit of current on this. I'll set it to 1 amp, I think. So let's just short it together. The output from the power supply. Oh, didn't like that much, did it? Ignore that. That's on a low ampage. What? Hi guys, welcome to Learn Electronics Repair. I have a power supply here that we looked at previously. It's not in the correct box actually, but this is the one. So we'll just get it back out of the box. It's a bit stuck. Ah. Okay, a little bit stuck there, and we have the various bits of it. So it's all over the place, yeah, it's all over the place. And here we have it. First of all, I'll put the rectifier diodes back in. Fortunately, this was actually fortunate. No. So let's see where we were. So I'll fix it, guys. As much as for any other reason that I'm pretty sure I have to 2 videos with them. So I'll fix it, guys. As I say, I'll have a look around. If I can't just find some salvage ones in about next week, I'll just order some. At least, as I said, I've said it already. So I will fix this, guys. I don't have a specific use for it, but I can probably make it. So I will fix this, guys. Okay, we're ready to try. I'll just leave the heatsink off for the moment. I just want to see. No, we're not ready. Okay. Now we're ready. Okay. Okay. So let me just pop the heatsink back on. I've removed the main switching transformer just to make it easier to see, to be honest. So from the positive end of the bridge rectifier, we should find a connection to one of the switching transistors. There, okay? So from the positive end of the bridge rectifier, we know is here, goes to, why is that fucking doing this? From the positive end of the bridge rectifier then, we'll have a connection to the collector of one of these transistors, which is the middle pin. We'll have a connection to that one. From the bridge rectifier positive then, these are the two switching transistors. The collector is the middle pin, and one of them will be connected to the positive of the bridge rectifier. Which is here. From the positive of the bridge rectifier then, this will connect to the collector of one of the transistors. Well, that's reading 6 ohms. That one doesn't go. It is this one. The reason it's reading 6 ohms is this is the little thermistor I told you about. The black thing that looks a bit like a capacitor, yeah. So that's the thing that stops the inrush current. It's reading 6 ohms. So here is our PCB, our transistor. I have a 22 watt 12 volt light bulb on here, so effectively at 12 volts, if it was 24 watt, that would be 2 amps. This is going to draw a little bit less than 2 amps at full brightness, okay? I'll just actually bounce the light bulb up on something so as not to burn the desk. I may well burn the solder reel, but that's not quite so important. Yeah. Let's see what happens. So we're going to switch our bench power supply on first. The bench power supply is here. This is a dual supply. So I've got it set to 15 plus 15, which is 30. So this black wire, this is your 0 volts. This is your 15, and this is your 30 volts coming in. So the 15 on the red and the 30 volts on the violet wire, that's your 2 voltage coming in, and this yellow wire, as the relay switches, will give us the input voltage we want, 15 or 30. That's how the circuit is designed to work, as I just explained, okay? So let's switch this on and let's have a look to see what happens. Well, it made a lot of clicking noises, that's the first interesting thing. And the light bulb came on. I'll just turn the actual output voltage down. Let's try again. Okay, the bulb's out. And if you can see on the power supply, we're only using at the moment the 15 volt supply. This says 31 and 31. But that, oops, and something smells. Wow. Did you see that, guys? We have a resistor down here burning. Okay. We have a resistor there burning. That is this resistor, 39 ohms. Let's have a look on the schematic. You usually find with these, if they've not been used for a long time, which this probably hasn't, you have to give them one thump to make the tray open, and after that they're reliable. So we'll start the PC and then see, it should open. Okay, press the button. You see, and after you've opened it once, they're fine. After they've opened once, they'll normally work reliably. Okay, a couple of times, but once you've done it, they will normally work. Okay, 3 times. Maybe I'm holding slightly upwards. Give again. Now this one's been a little bit temperamental. Oh, that time it's opened, okay, so that time it just opened. So after you've done it a few times, normally they'll work just fine. Okay. Here are some preset or trimmer pots or preset potentiometers. You'll see they come in a variety of different types if you like. Some, like these, are multi-turn ones. These are horizontally mounted, some are vertically mounted, but they're all basically the same thing. They will normally be marked, if they're marked at all, with the value of the resistance. So this one says W500. That is not a 500 ohm potentiometer, it's 50 and no more zeros. So that is a 50 ohm. Yeah, and I think all these in this little batch were all 50 ohms. But if you're not sure, you can find out by just measuring across either end of the track. So we're on ohms range, and if we just measure across, hi guys, welcome to Learn Electronics Repair. I've made a few changes to the recording system. So I've now got the original camera set up, but I'm using it on a new PC, which is a lot faster than the other one. It also has a fairly fast GPU in it, which the other one didn't have. So before I was just using a GTX 750 Ti. The machine had 4 gig of RAM, running Windows 7 32. Hi guys, welcome to Learn Electronics Repair. Just before we start, I've made a few changes to the recording system. So I've actually changed the computer that I was actually using to do the recordings. So I had an i7 for, what is it? Hi guys, welcome to Learn Electronics Repair. I've made a few changes to the recording system I'm using, so I actually have another PC now, which I'm going to try, and then I will be making more changes over the next few weeks or a couple of months. So basically what I've done is I've replaced the i7 4th generation machine I had. It had the fastest available 4th gen i7 in there. I can't just think what it was now. but it had 4 gig of RAM. It was running Windows 7 32-bit. It's a machine I've had for a long time, and it was doing pretty well, to be honest. So I've now got an i7 7700K. This is the one I got from the car boot sale a month or two ago, a couple of months back. So I'm now using that one with the motherboard that came with it, which actually is a Lenovo board, but it's a full-size ATX, so that's what we have. I now have an NVMe drive, which is the OS drive, and it's running Windows 10 64-bit. So I've upgraded it somewhat. 16 gig of RAM DDR4 now. So that's kind of what I'm using. I'm still using the original camera setup, and I might as well stop because the face cam stopped working. Hi guys, welcome. Hi guys, welcome to Learn Electronics Repair. Hi guys, welcome to Learn Electronics Repair. So it's that time of the week again, and it's car booty time. Yeah, and we have some different stuff this week. But I'll just mention first, I upgraded my computer over the weekend. This is the first. What is wrong with the f***ing camera? Hi guys, welcome to Learn Electronics Repair. Just before I start, I'll just mention I've actually upgraded the computer. In fact, I've replaced the computer I used to make the recordings. At the moment, all the camera system is still the same as before, but I will be upgrading that too. However, I want to make one change at a time, and straight away you can see this isn't f***ing working because the face camera keeps going off. I'll also just check that pin 7 of this chip goes to the ground on the out. That's the most likely place, because we need to know where to take our measurement from. We need a ground reference. And that does, right, so I'll just put it where you can see it. I'll just check also that the ground on this chip, which is pin 7, which actually would be pin 4 on this one. Yeah, it goes to the ground here, the minus out. Yeah, so we know that's our reference point. So when we take this measurement from here to here, because we've had a look around this circuit, we know what we're expecting to find, what it means if we have no voltage here, and I'll take these devices back off again. We can test them all, and then we can have a look to see what's happened to this. What? I'll take all these devices back off the board. That's the good thing about the fact I just tagged them on there. And then we can test all of these individually and see what's actually happened to this.